Okay, continuing on with lesson 2.8. So now we're talking about finding where a rational expression is zero, positive, or negative. So it says let f of x equal that equation. Determine the real number of values of x that cause f of x to be zero, undefined, positive, and negative. And so really the only difference between what we're going to do now and what we just finished in the other videos is now this is actually a rational function. Now we have x in the denominator. Because we have x in the denominator, that also means that we could have a vertical asymptote. Excuse me, so we're going to have to check for it. Remember that in our interval table, the intervals were created by the vertical asymptotes and the x-intercepts. So those vertical asymptotes are also the critical values. And so it has us, we're going to find the zeros, which remember is the same thing as your x-intercepts. And you find them by setting your numerator equal to 0. And we're going to find the where it's undefined, which is your vertical asymptote. And we find that by setting our denominator equal to 0. And then we'll look for where it's positive, which is going to be where it's greater than 0, and where it's negative, so where it's less than 0. All right, so the first thing let's do is let's find those zeros, those x-intercepts. And so for A, remember you just take your numerator and set it equal to 0. It's already factored for us, so we're going to take those individual factors and set them equal to 0. So x plus 3 equals 0, x minus 5 equals 0. Solve them both, so we have zeros at x equals negative 3 and at x equals 5. For B, we're looking for whether it's undefined. That's that vertical asymptote. That's going to be where the denominator equals 0. So 2x minus 1 equals 0. Add the 1. So 2x equals 1. Divide by the 2. And so it's at x equals 1/2. Remember, both of these together create those critical values that we're going to use in our table. Now, before I can do C and D, I'm going to go create my table. So I'm going to do my interval, x's, y's, and then the sign. So I'm going to use plus or minus. All right, so our interval is always going to start with negative infinity, and it goes to our smallest critical value, which is our negative 3. Then we go from negative 3 to our next smallest critical value, which is the 1/2. From 1/2, we go to our next smallest critical value, which is 5, which is also our largest. So from 5, we go to positive infinity. Remember, your infinities will always have parentheses. And also, because your vertical asymptotes come from your denominator cannot equal 0 in your domain. So therefore, your vertical asymptotes will always be parentheses. So at the 1/2, I'm going to put a parenthesis on both of those. Now, your x-intercept will depend on what your inequality is, okay? And so here, they didn't give us an inequality in the problem, but we're looking for where it's positive, which is only where it's greater than 0, and where it's negative, only where it's less than 0. So it's not equal to on either one, so we're going to use parentheses on both of those then. If it had been greater than or equal to, less than or equal to, we would use brackets on the negative 3 and the 5. All right, so we're going to pick a number in each of these intervals, and we're going to plug those into our equation to see what we get. All right, so when I plug in negative 4, I get negative 1. When I plug in 0, I get 15. When I plugged in 1, I get negative 16. And I plugged in 6, so I get 0.82 approximately, which is positive. All right, so when I'm looking for on C, where they're positive, I'm looking for greater than 0. I'm looking for where it has a plus in the plus or minus column, the sign column. So I can see it's from negative 3 to 1/2. And it's also from 5 to infinity. Then for D, where it's negative, that's where it's less than 0. I'm looking for negative in that sign column. I can see it's from negative infinity to negative 3. And from 1/2 to 5. And so we could graph those as well, and we would see the same thing in our graph. All right, so let's do some more practice here. So it just goes through the steps, talks about everything we just did. You can read through it. And so let's just do some more. So let's solve and express your answer using set interval notation. So the first thing I need to do here is I need to find those critical values. And so those critical values are those things in my intervals, the points in the breaks in my intervals. So we know it's going to be our x-intercepts, which remember is our numerator equal to 0. So solve it. And our vertical asymptotes, which is our denominator equal to 0. So those are my two critical values. And so now when I go to make my table, and it's going to be from negative infinity to 3. I'm sorry, just kidding, to negative 2. Negative 2 to 3, and 3 to infinity. Now let's look at our inequality here. First thing I did not mention here, but we talked about it in class, is that it has to be less than 0, greater than 0. So it does have a 0 there. Greater than 0 tells me we're looking for where it's positive. I also notice there's no equal to, so that means that my x-intercepts are going to have parentheses. Remember, your vertical asymptotes are always parentheses. All right, so the vertical asymptotes are always parentheses, so the negative 2 will have parentheses, and for this problem, the x-intercepts are going to have parentheses as well, so the 3 will have it. So I'm going to pick an x value in each interval, and I'm going to plug this into my equation to find its y value. All right, so negative 3 I see as a positive 6, 0 is negative 1.5, and 4 is approximately 0.2. All right, I'm looking for where it is greater than 0, so we said this are positives. So I can see my solutions right here. So negative infinity to negative 2 with the parenthesis, and 3 to infinity, 3 has a parenthesis as well. And so that is my solution. The line they have drawn over there was for that sign chart that they do with the textbook videos. So I just did my table down low there. All right, so continuing on, let's look at example 7. Now example 7 is different because it doesn't have a 0 on the other side. So the first thing I have to do is make it have a 0. And so we're going to have to get that with a 0, so I'm going to subtract the 5. So what we have here is x minus 2 over x plus 2 minus 5 is greater than or equal to 0. Well, now I still have to combine those two fractions there. So I need that least common denominator. And so I'm going to use kind of like what we did at the beginning here. I'm going to find the least common denominator. I'm going to multiply everything by it and then put it back over the least common denominator, because I'm not going to solve for x using it. So I can't just get rid of it like we did back in example 1 and 2. But we are going to use that method to help us simplify it though. All right, so my least common denominator, I'm going to put that one over 1. So it's just that x plus 2. So I'm going to multiply everything here by x plus 2. Well, actually, I don't even have to do the right side. I can, but since I'm going to put it back over, I don't have to. So I'm going to multiply both of these by the x plus 2. And so this x plus 2 cancels, so I got x minus 2. And nothing cancels here, so I have that negative 5 times the x plus 2. And because we're not going to use it to solve, we're going to put it over that common denominator. And then I still have my greater than or equal to 0. So I didn't do what I do to the left of the equation, I do to the right side. I did what we can do to a fraction. What I do to the top, I do to the bottom. Okay? And so now I just need to simplify that numerator. So I'm going to distribute the negative 5. So x minus 2 minus 5x minus 10 all over x plus 2. and then combine your like terms. That's what, negative 4x minus 12 over x plus 2 is greater than or equal to 0. And now that I've got it down to one fraction, I can go ahead and find those critical values and set up my table. All right, so my critical values. Remember your x-intercepts. So where that numerator is equal to 0. So negative 4x minus 12 equals 0. So negative 4x will equal positive 12, so x equals negative 3. And your vertical asymptotes is where the denominator equals 0. And so x equals negative 2. Remember, your denominator will always have a parenthesis. Your numerator, your x-intercept, is going to depend on your inequality sign. So go look at your inequality sign. You see it has an equal to, so therefore we're going to use a bracket this time on the negative 3. All right, so let's set up our table. So negative infinity to the smaller one, which is negative 3. And we said we're going to put a bracket at the negative 3. So the negative 3 to negative 2, which we said is going to have a parenthesis. And negative 2 is our biggest one, so it goes to infinity. So pick a number in each interval. Ooh, that one's not pretty. That's okay, we can handle it. All right, so let's plug these into our calculator. Now, if you are using your y equals to do this, guys, or even if you're not, when you're plugging them in, use your simplified one here, okay? Use it where it's got that 0 because we're comparing it to positive or negative. That's where 0 is neutral. You don't want to use the original problem this time. All right, so let's plug these in. Negative 4 gave me negative 2. 3, I'm skipping one there, gave me a negative 4.8. And then the negative 2.5 gives me a positive 4. All right, going back to where it has a 0. Are we looking for positive or negative? Well, it's greater than or equal to 0. The greater than numbers are positive. So my answer is going to be where my numbers are positive. So I'm going to go back in my table. And I can see where they're positive is from negative 3 with a bracket to negative 2 with a parenthesis. So that is my solution. All right, then moving on to example 8, other inequalities. And so this is similar to the other one. We've just got two fractions instead of one fraction. And so we're going to work it just like we did example 7. So we need to find our least common denominator. And so I can't factor out either denominator, so I know that least common denominator is going to be the 2 minus x times the x plus 4. And so, whoops, hold on. I jumped ahead of myself. Sorry. First thing we got to do is set it equal to 0. So let's move one of these over. I like 0 to be on the right. It's just easier to me, but it could be on either direction. All right, so I get 3 over 2 minus x minus 1 over x plus 4 is less than or equal to 0. Now for us trying to do that least common denominator. I can't factor out either one, so I know it's got to have the 2 minus x for the first fraction, and it's got to have an x plus 4 for the second fraction. So I'm going to multiply, because I'm not solving using this. I'm just going to simplify this to a single fraction. I'm going to multiply both this one side, everything on one side, by the 2 minus x and the x plus 4. And so I get 3 times x plus 4 minus 1 times 2 minus x all over that least common denominator. So 2 minus x times x plus 4. And then we still have our less than or equal to 0. So I'm going to distribute. And I'm not going to distribute on bottom, because on bottom we're already factored, and that's where we're going to want to be. So combine my like terms. Oops, forgot my less than or equal to 0. Combine your like terms on top. So I get 4x plus 10 over the denominator, less than or equal to 0. And now we're ready to find those critical values. So before we get going on that, though, I can see I'm looking for less than 0, so I'm going to be looking for where it's negative, and it has an equal to, so that means my x-intercepts will have brackets. So don't forget. All right, so my critical values, my x-intercepts, where the numerator is equal to 0. So 4x plus 10 equals 0. Subtract the 10. So 4x is negative 10, divide by 4, so x is negative 2.5, or negative 5 halves. And we said x-intercepts are going to have a bracket. My vertical asymptote is where the denominator is equal to 0. Well, I have two factors there, so I have two vertical asymptotes. So I'm going to set them each equal to 0. So 2 minus x equals 0, x plus 4 equals 0. I get 2 equals x, and x equals negative 4. And we said that vertical asymptotes always have parentheses. All right, so let's set up our interval table. So my interval, my x, my y, and my sign. So negative infinity to the smallest one, which is negative 4 with the parenthesis. Negative 4 to my next smallest, which is negative 2.5 with a bracket. The negative 2.5 to the next smallest, which is 2 with a parenthesis. 2 is also my largest, so 2 to infinity. So let's pick some x values that are in between these numbers. And then let's plug them into our equation. Now use the equation we had down here, okay? It's simplified, and it's got 0 on the other side. You can use any of them once you get the 0 on the other side. Just depends on, how hard you want to work to type it in, I guess. All right, so I do this. My negative 5 is 1.4 something, so it's positive. Negative 3 is negative 0.4, so it's negative. 0 is 1.25, so it's positive. And 3 is negative 3.1 something, so it's negative. And so, looking back, we said we were looking for less than or equal to 0, which is where it's negative. And so we have here and here. So negative 4 with a parenthesis to negative 2.5 with a bracket. Union 2 with a parenthesis to infinity with a parenthesis. And there is our solution.